Okay, Unit 2 review. I can intelligently prepare for my final exam. Number 1, how to prepare. We can look at videos that we did on our notes. Number 2, we can read our notes that we took in class. And number 3, we can practice the review that we are doing right now.
Or the review that you've had since the beginning of the chapter, right?
Yeah.
And then the fourth thing I would argue, I'm going to add this, I forgot to say this one, is I would study smart. In other words, study what you don't know, skim over what you do. Don't skip what you know, skim over what you know. Still review it. All right, this is what the test is going to consist of. You are going to have to find prime factorization. You are going to have to find prime factorization using a factor tree. Here's an example of a factor tree. Here's an example of the prime factorization. Here's an example of the final answer in exponential form. Check, done. Next thing you're going to have to be able to do is list factors. When we list factors, we use factor pairs. This is an example of finding all factor pairs for a number like 12. If you draw a U, they are in sequential order. You are also going to have to find the greatest common factor of 2 or more numbers. You have two options of doing, or 2 ways of doing this. I don't care which way you do as long as you do one of the 2 ways. One way would be to use factor pairs for both numbers and find the biggest common factor. The second way would be to find the prime factorization for a number like 12 and the prime factorization for a number like 16. Find the prime factors that they have in common, which happens to be a couple of 2's, multiply them together, and 4 is your GCF. Got it? Equivalent fractions. Somebody give me the 2 ways we can calculate equivalent fractions. Give me both ways, Veda.
Reduce or multiply.
Reduce or multiply. If you were going to multiply to find an equivalent fraction, what would you multiply by?
The numerator and denominator.
By what?
By the same number.
By the same number. Excellent, Veda. Beautiful. Number 5, LCM. How do you find LCMs, Tyler? You list the first 5 multiples of each number, and you find the one that is the one that is the smallest but in common, right? If you can't find one after listing the first 5, what do you do, Tyler? You keep going until you find one. Thank you. Ordering fractions. What must you do when you have 2 fractions with different denominators? Matthew, what must you do when you have 2 fractions with different denominators? You're not listening to me, Matthew. You list all 5 factors. Why would you find factors when you're looking for a common denominator? Amr, what do you do? You can multiply the denominators by each other. Yes. What else could you do? Amarami. Find the LCM of the 2 denominators. So if you have 3 and 4, find the LCM, which happens to be 12. You also, as Amr said, could multiply them together. It's not always going to be the LCM, but it works. Awesome. Once you have a common denominator, then you can determine which fraction is bigger or smaller.
Number 7, converting mixed numbers to improper fractions and vice versa. We are doing our mixed number, which is 3, and then 2 over 5, and we're going around the world. So we're taking 3 times 5, which is 15, and then we are adding 2 to that, and that would be 17 over 5. Always bring over your denominator, which is 5. Then for the next example, we have an improper fraction, and we're converting it to a mixed number. 17 over 5. We're taking that, and we're putting it into a division problem. 5 divided by 17. When we're doing our division problem, we have our denominator, which is 5, our remainder, which is our numerator, and then our whole number, which is 3, and that's what we got for our answer.
So the numerator always goes in the box, and the denominator goes outside the box?
The denominator goes outside, the numerator goes in.
Yep. That's what I said.
Yeah.
Okay, cool. And decimals to fractions. How do you go from a decimal to a fraction? How do you go, Yusra, from a decimal to a fraction? You read the decimal, right? That's it. And how do you go from a fraction to a decimal? How do you go from a fraction to a decimal, Mukta?
You divide.
You divide. What goes inside the box? What goes outside the box? Good. And you always round to the nearest, unless you're told otherwise, right? Sweet. Any questions?